graphing lines, I'm going to show you 3 different, maybe 4 different things about graphing lines. Sketch the graph of each line. The first thing we did was from a table. We need to know how to fill in a table. I'm going to put an XY table here. I'm going to put another one on this side. So I have one on each, okay? Now, the key with this is my input, my X. Whatever those numbers are is your choice. Pick good ones. Pick good ones. Okay, now problem 2 has a fraction, so I'm going to have to be particular there. But problem 1, I have a 2. I just need to pick easy numbers. So my easy numbers here are 0, 1, 2. Maybe some negatives, that would be appropriate, but 0, 1, and 2. And all I'm going to do is plug these in. So watch. Y equals 2 times 0 plus 4. What is 2 times 0? 2 times 0 is 0, so that means we get 4. Boom. Y equals 2 times the next number, 1 plus 4. What's 2 times 1? 2 plus 4, that's 6. Y equals 2 times 2 plus 4. What's 2 times 2? 4 plus 4, 8. So there's my table. Now it shows me that my numbers have to be correct, really good, I should say, whatever. But 0, 4, over 0, up 4, over 1, up 6, over 2, up 8. Oh no, I went off the graph. Well, if I'd have been even smarter, let's go pink, let's go with a red, let's go blue, let's go green. If I'd have chosen a -1, then I could go y equals 2 times -1, which is -2, plus 4, which is +2. If I put a -1, I get a +2, and you can see it's on the graph. I don't need 3. I don't need 3, but I like it. But that's a table. Just choose good points. You know, I saw some people choose, 6, 7 because they, oh, that's funny, whatever. But you know what? 7's not even on the graph. 6 way over here. We need numbers that'll fit in our graph. Okay. Now, try another one. If we do this, now again, that negative sign, I'm going to let it be part of the 7. Let me write it again above. I like -7 over 3 rather than the negative out in front. Doesn't make too much difference, but I like to know where that negative is part of. In this case, because of the denominator, I want to choose multiples of 3. Multiples of the denominator. And that's real easy. -3, 0, +3. If I had other numbers, I'll throw one more, 6. Or -6. I wouldn't choose 1 and 2, 4 and 5, because they're not divisible by the denominator. So watch what happens. Y equals -7 over 3 times -3 plus 2. This -3 I can make it look like a fraction, which helps me see, oh, these cancel, give me a -1. 7, -7 of -1, +7 plus 2, that's 9. Okay, 9's not on my graph, so that kind of sucks. But let's keep going. Y equals -7 over 3 times 0 plus 2, that's just 2. 0 times anything is 0, so that's 2. So 0, 2 is on my graph. Y equals -7 over 3 times, I'm going to make this 3 over 1 right off the bat, plus 2. Plugging in 3. So the 3's can cancel. I get -7 plus 2, which is -5. Y equals, watch this, -7 over 3 times 6 over 1 plus 2. Okay, well, 3 goes into 6 2 times. 2 times -7 is -14, plus 2 is -12. Okay? So in all of this, I got 2 different sets. I'm just plugging in numbers. I got 2 different sets This one and this one are bad because they go off the graph, but I do get over 3 down 5 way down there. And I have two dots, not 3 like I would usually like, but 2 dots, and I can graph. But I choose, whenever I have a fraction, I choose multiples of that denominator. So if it was a 2, I would choose 0, 2, 4, 6, 8, even numbers. If it were a 4, I would choose 0, 4, 8, 12, things that are multiples of that. All right, that's a table. You should know how to fill in a table to graph. It's not a big deal. But here's the nice part. We have this slope-intercept form, y equals mx plus b. M is how we move. That's our slope, and b is where we begin on the y-axis. B is the y-intercept. So if I look here at this problem, m would be -1 in front of the x, and b would be 3, the constant. Now, remember, slope is rise over run, so if I need this to be rise over run, I'm going to have to consider it like over 1. So now I begin at 3 on the y-axis. If you plug in 0, y equals 3, so 0, 3. And then this says go -1, down 1, over 1, and we have our graph. Pretty straightforward, easy. Pretty straightforward. Could we have done it on those table ones? You bet we could have. But we should know how to fill in a table at the same time. So take a look here. There's my negative, so m is -5 over 4. I put that to the top. And b is -1. M is in front of x, b is the constant. So I go to b is -1, y-intercept, down here. Do not go over. X is 0, over 0, down, over 0, up. B is always up and down. And then this says go down 5 over 4. So 1, 2, 3, 4, 5. Whew, just made it. 1, 2, 3, 4. I'm not able to do that again. But watch, instead of down 5, right 4, what if I went up 1, 2, 3, 4, 5, left 4? Look at that. I can go in reverse, and that's where I would say it's a +5, -4. Put the negative to the bottom number, but only because it benefits me. But again, I got both graphs. And again, this right here, on both of them, that is my y-intercept. That's where it crosses the y-axis, which we get, that's b. Crosses the y-axis at b. All right, two more sets, but in these kind of problems, I have trouble. Let me rewrite this down here. This one won't be so bad. I don't like this style. I would rather transform that into y equals mx plus b. Well, it's simple. You get x on the other side of the equal sign. So now we have y equals. These are not like terms, but rather than write it this way, what if I didn't write it that way and I wrote it with the 2x in front and the 3 behind? See, that way it looks like my formula. M is -2. Remember, rise over run, so let's put it over 1. B is -3. So a little quick shift, taking my equation and rewriting it into this form. Now I can put a dot at -3, the y-intercept, -2 over 1, so that's down 2 over 1. Down, oh, can't do that. Let's go up 2 the other way. Go in reverse, and I have my line. Okay, the next equation, I'm going to just keep down here. It says 4x plus 3y equals -12. So let's convert that into slope-intercept. Subtract the 4x. Get x and y on different sides. 3y, let's put the x first, and then the -12. Be careful, sometimes it's positive, so you put plus. Now, this y has a coefficient, so let's divide by that coefficient. And when we do, let's divide each. So we get y equals -4/3 x minus 4. M will be -4/3, down 4, right 3. B will be -4. So if B is -4, we get a dot right here at -4. Down 4, oh my goodness, I can't go down 4. So remember, the negative can shift. We could do 4/-3, and it's the same thing, but only when it suits us, only when we want to. So let's go up, 1, 2, 3, 4, right, left, 1, 2, 3, 4, 1, 2, 3. And that's going to give us the same exact graph as the others. Boom, oh, black line. Okay, so taking one form, standard form, and rewriting it, make sure it's in that y equals mx plus b form, makes graphing really easy. Finally, there is something, we didn't do it in class, but can we graph a line given the intercepts? Yes, absolutely, piece of cake. The x-intercept is 3, so that means it crosses the x-axis at x equals 3. The y-intercept is 4, so that means it crosses the y-axis at y equals 4. I have 2 dots. I have a line. If we understand the concept of x-intercept being where it crosses the y-axis, y-intercept being where it crosses x and where it crosses y, we're fine. How do we do this one? X-intercept, -5, so that's over here, x-axis. Y-intercept, +2, that's here, y-axis. I only need 2, I don't need 3. I like 3, it's helpful, but I only need 2. Boom. My x-intercept is on the x-axis, and my y-intercept is on the y-axis. So there's a little extra for you.